So these are the three reaction intermediates which we will discuss. Okay, reaction intermediates, and these are of uttermost importance. So firstly, let us begin with carbocation, that is C plus. Okay, so this name is carbocation, and it is formed. We have seen yesterday like how it is formed. So carbocation actually, if I go through the chemical bonding, how can it be formed? Like suppose carbon is having like this 4 bonds, yes. And if one hydrogen is away, see one hydrogen goes away because carbon electronegativity is 2.5 and hydrogen is 2.1. So preferably the bond, the shared pair of electron will go towards the carbon end because it is more electronegative. So if these situations happen, what will be there? We will have C negative, correct? So carbon anion will be formed. But if this is the possibility, suppose carbon is having some hydrogen and hydrogen and hydrogen, and I have Cl here, yes. And if this Cl goes away because Cl is more electronegative, then I can have carbocation, correct? So the attaching group, like this group should be more electronegative than carbon, so that carbocation can be formed. Okay. So once the carbocation is formed, it looks like this form. So this is R is any alkyl group, yes. R is any alkyl group. Maybe hydrogen you can consider this is any alkyl group. Okay, so these are like, or you can much better you can draw like this, much better way. So this is like and this is the third one. Okay, these are the three. This is trigonal planar, and this one is the empty p orbital. This is the empty p orbital or vacant p orbital. Vacant p orbital for this carbon atom, and we will have a positive charge over it. So this is a carbocation. So this is how carbocation looks. So the properties which we need to remember for this, the shape is like the geometry is trigonal planar. Okay, trigonal planar. Okay, we have three like just like boron trifluoride we have. This is trigonal planar, correct? We have to ignore these MTP orbitals. Second thing we have to like take away from this is lone pair here are zero. Lone pair is the number of lone pair is zero, and the number of bond pairs. Can you find out how many bond pairs are there? 3. Okay. And can you tell me the number of electrons on this carbon, like carbon center? Total electrons? They are 6. Very good. So there are 6 electrons here. And because there are 6 electrons, I can say all electrons are uh, like there is no unpaired electron. So unpaired electron here is unpaired electron is equals to 0. So this species is by nature this is diamagnetic. Diamagnetic are those species or those compounds which do not get attracted or repelled by a magnetic field. So how to check whether somebody is diamagnetic or paramagnetic? So diamagnetic, which has no unpaired electron, which has no unpaired electron is diamagnetic. Okay. So these are the few things which we can like, and it is electrophile. It is electrophile. It is E plus. Why? Because there is shortage of electron. 2 electrons are short. There are only 6 electrons. Okay. And these all reaction intermediates are unstable. These are short-lived species. Short-lived. So these are very unstable. Okay. So this is basically about like a carbocation, how carbocation looks like. Yes. And you can replace this R. R is any alkyl group. R means any alkyl group. R is any alkyl group. Or you can take R as hydrogen as well. Okay. This is also a carbocation. If you draw like this is also good. If you draw like this is also a carbocation. Correct. Now, there is one more thing which I want to say. Like we were talking about stability. Okay. So in terms of carbocation, for stability, firstly you have to understood like there are three types of carbon. Yes, one is primary, then there is secondary, and then there is tertiary. So primary carbocation or primary carbon. So basically, from definitions, like a primary carbon is such a carbon which is attached to only one carbon atom. Yes. Like the number of like suppose if a carbon atom is attached to two more carbon atoms, so then it is secondary. Now if it is attached to three more carbon atoms, then it is tertiary. If it is attached to four, then it is quaternary. Okay. So I am talking about this carbon only. Yes. So this one is primary, the green one. So for primary we write 1 degree. For secondary we write 2 degree, and for tertiary we use 3 degree. Okay. So this is primary. This one is secondary, and this one is tertiary. Okay. So it is like one carbon atom is linked to how many carbon atoms? Yes. So that defines it degree. Okay. I hope like you have understood. Okay. Now in this carbon, like in this one is also primary. Here this one is primary and this one is primary. Correct? Because it is attached to only one carbon. Yes. I am not satisfying all the valency. So it is understood like if I have written the single carbon, so it means the remaining valencies are satisfied by the hydrogen. Okay. So let me ask you one simple question. Suppose if this is a question. Okay, so this is the question. So you have to identify the degree of carbon. I am writing like A, sorry. So you have to tell me the degree. A, B, C, and D. Yes.
Uh, A is primary,
A is primary, very good.
B is tertiary.
B is tertiary, B is quaternary.
Okay, oh, it was even higher. Okay, okay, got it.
And
Then C is tertiary.
C is tertiary, very good.
Primary.
D is primary, correct? And what
Yeah.
about this one?
Um, that, that's it.
This one is secondary. Yes, two carbon. Okay. So this this is attached to one carbon here and one carbon here down. So only two carbons are attached. So this is secondary. Okay. So now for carbocation, the stability order is stability of carbocation. So the order is tertiary is greater than secondary is greater than primary. Okay. So this is the stability of carbocation. Okay. So in your books, like you can see like this thing like tertiary, secondary, primary, and then you just have to memorize this. Yes. So it is hard if you can find like explanation behind this. And maybe if you can find, you cannot digest easily. Okay. So we will be discussing why. Yes, because we have to understand organic, like why it is their side like tertiary, secondary, and primary. Correct?
Yeah. Okay.
So if this is the case, then my question to you was like yesterday we ended up some question and I said you like you will tell me. Okay, so this was the question, yes. So can you tell me what is the stability order in this? So you just have to identify the degree of carbocation first. So the first one is like this carbon is
Tertiary. Sorry,
this primary,
tertiary.
yes. This one is
Primary. Okay, primary.
this is hydrogen.
Tertiary.
So see,
Yeah,
you
yeah,
have to check only carbon,
yeah,
yes, not any other
yeah,
thing.
okay, got it.
And
Okay,
this one
that's second.
secondary, very good. So the order will
Second.
be stability order will be second is more stable, then third, and then first.
Yeah.
Correct?
Yeah.
So it means the question was if Br minus is going to attack on this, so it will attack this one very fast. Okay, now it means like this compound will be formed very fast, or this will be the major product, correct? Because I said you like the intermediate which is most stable will give the
What?
most stable reaction intermediate will give the major product, correct? So that's why we have to see all this. Okay, don't worry, you will be playing with this. Yes, don't worry. It may be like you will wonder like, oh, how will I recognize all this? I have to memorize all this. So it's just a day two. Yes. So
Yeah.
remember like how long you took to remember all A to Z, A B C D, all and all that making letters. So chemistry is a language. Yes. So it takes some time to just know the keywords. Then it is very easy. Now there is one more thing that is known as hybridization. I hope you know this.
Yeah.
So hybridization for carbocation is sp2. Now how come? Like how did this come? We will be discussing. Yes, very soon. But you just remember like sp2. I will be showing all the cards. Okay. So next is free radical. Free radical we are taking free radical. Is it all clear in carbocation?
Yeah.
Okay, okay. I will be like giving the reason as well, but for that we have to study another thing. Yes. So we will come to that, and that is very important. So free radical is carbon, and it is having one electron with him. So how it looks like? So it is like carbon is having like just like there is some alkyl group, there is some another alkyl group, there is another R, and then there is a p orbital, vacant p orbital. But in this vacant p orbital, we have one electron. Okay, we have no charge, but we have one electron. So now total electron in this is
So why did it go chat? Oh,
sorry.
yeah, no chat. Got it.
So we have seven
Yeah.
electrons, six already, and is it all clear?
Yeah. Yeah.
Okay. So total electron is seven. This is free radical, carbon free radical. So total electron is seven, and then hybridization is again sp2. Yes. Geometry
Okay.
you can again say it is trigonal planar. Geometry or like shape. Geometry is trigonal. Like shape is trigonal planar. The
Yeah.
right
Okay.
shape is trigonal planar, and this compound is paramagnetic. And the
Okay.
reason being because there is one unpaired electron.
Okay.
Yes,
Yeah.
in p orbital. Maybe some another day we can discuss chemical bonding to know all these effects. Okay. And what is remaining else? Lone pair is zero. Lone pair is zero. And bond pair are three. Correct. So see, how will you find the hybridization? I am showing you the trick. So in organic
Yeah.
chemistry, there is another formula for calculating hybridization. So what is this? You have to count the number of sigma
What?
bonds. Do you know what sigma bonds are?
Yeah. Okay.
Yes.
So the
Number of sigma bonds, and you have to add lone pair.
oh,
Yes.
okay.
This is the
Yeah.
formula for hybridization. Okay. So if this value comes to like this is electron pair is equals to number of sigma bonds plus lone pair. Like electron pair is equals to uh, number of sigma bonds plus lone pair. So this is the formula we will use. Okay. So how it works? So electron pair value, if it comes to be like 2, the compound is sp. If it comes 3, it is sp2. If it comes 4, it is sp3. So this is the trick. Okay. So you need to remember this. Not every time you have to draw all the structure and do all the nonsense. Okay. So this is the way we can use. And one more thing, negative charge. Negative charge means 2 electrons. Yes, 2 electrons. So that can be equivalent to 1 lone pair. Okay.
Okay.
Okay. So let us check hybridization. So please now, and sigma bond, you know what sigma bonds are? Sigma bond is just a single bond. Okay.
Yeah.
Sigma bond is single bond. You don't have to take pi bond in this, only sigma bond and the lone pair. Okay. So let us take this question, this one, and let me check if you can find out the hybridization of this. Because in organic, we have to know the hybridization of each. Yes. So we start with carbon A. So what you can do, you can imagine, just you can draw this in expanded form, like 3 hydrogens are there, correct? And it is attached to 1 carbon like this.
Mhm.
Now this is A carbon. Now you can think of, like, there are 4 sigma single bonds. So it is 1 sigma, 2 sigma, 3 sigma and 4 sigma bonds, correct? So number of sigma bond is, so electron pair is 4 and lone pair is 0. Carbon is not having this central 0. So electron pair is 4. So 4 means sp3. So this carbon is sp3 hybridized, correct? Okay. So can you tell me the hybridization of this carbon, the B carbon? Yes,
Any,
the B carbon,
yeah, SP3.
sp3. Very good. The C, this C carbon.
SP2. Wait. SP3, SP3.
Don't forget to take this hydrogen behind
Yeah.
this carbon. Yes. Okay. So all are sp3 if you find out. Okay. You
Yeah.
can enjoy. Yes, you can enjoy. Okay. So now suppose if something is like this, suppose this is carbon and this is hydrogen, this is hydrogen, this is hydrogen, and there is a positive sign. Looks like carbocation. Yes. Now can you tell me the hybridization for this? I know, you have just seen, but can you calculate by the formula?
Yeah. It is three bonded pairs and zero lone pair.
Yes.
SP2.
So sp2, correct?
Yeah.
So there is 1
Mhm.
sigma, there is 3 sigma. So on 3, the term is sp2, correct? Now for
Yeah.
free radical, can you tell me the same? Like suppose if I have free radical,
Yeah. Uh-huh.
again it should be sp2 because there is no lone pair,
Okay. Fine.
correct? And if I take this one, can you tell me? Now I am taking carbanion. We will be discussing stability just now after this one. So carbanion, for carbanion, like carbon is there, and we have R, R, and R, and we have this thing.
SP3.
So can you tell me the hybridization for this?
SP3.
sp3. Very good, excellent. Because there is one lone pair, so you just include one more. So 3 plus 1 is 4. So that is, or you can draw this as like this as well. C minus, and this is R, R, R. So shape is actually, the shape is for this is pyramidal, correct?
Mhm.
For carbanion, shape is
Yeah.
pyramidal, and lone pair is 1, bond pair is 3, hybridization is sp3, correct? And this is actually diamagnetic in nature, and this is nucleophile, correct? Because this is
Yeah.
electron rich, electronically rich. Okay, so now maybe you are much more familiar with the reaction intermediates. Now the stability order for this carbocation is the same as this is tertiary, secondary, and primary. Okay, is same as that of carbocation. Yes, means carbocation and free radical somehow like they share the they resembles some property. Yes, and now for carbanion the stability order is the stability order for carbanion is like this is reverse 1 degree, 2 degree, and then 3 degree. Now there may be a question in your mind like what nonsense is this? Yes. How do I agree? Okay, so we will be exploring this now. Okay, is it clear now? Like what are carbocations, carbon and free radical? Okay, so
Okay,
we will be
this is the
discussing.
last thing. The switch. The we just discussed directly because my Wi-Fi